take this problem. Now tell me. A vessel of depth D is half filled with oil of refractive index N1 and the other half filled with a refractive index N2. The apparent depth of the vessel when viewed from the above is. This is similar kind of problem, isn't it? We have seen earlier. So if I consider this is some vessel, this is half filled with the two types of mediums, right? Is half filled with oil. So this is filled with a oil having refractive index is given as what you tell me now, N1. And this other half is filled with a water. So this is oil, refractive index is N1, and this is water, refractive index is N2. And then how much this value, tell me now? This is D by 2 and this height and which is D by 2, right? Now here the person is observing from the top view here. Now you tell me now what will be the apparent depth? How much?
So I can explain.
Yesterday we have seen this problem now. This is similar kind of problem, isn't it?
Yes, sir, but it had values, sir.
So here, so N1, N2 given now, we can put N1, N2. The answer is in terms of N1, N2 only na. So tell me now what is the apparent depth formula? So this is apparent depth which is equal to what, tell me now? A refractive index of observer into what, tell me now here? So this is real depth by refractive index of object OBJ. Here the number of mediums are there. So in this case, dA, which will be refractive index of observer. Here, where is the observer is doing now here? When viewed from above, that means top view. So this medium we can treat as not mention or take it as air. So refractive index of observer is how much now? 1 into what you tell me now here? dr. What the dr is a, so from here this oil depth is what, tell me now? D by 2. Refractive index of this medium is how much now? N1. Okay. Plus, now this is D by 2 by refractive index of water, that is how much now? N2, isn't it? Yeah, simplify and get it. Then how much this dA value now here? Yeah, we can take out the D by 2 common. So LCM we have, that is N1 plus N2 by N1 into N2. Right. Now what's the option?
Sir, option 2.
Option 2. Isn't it? Understood? Simple na? Same as yesterday's problem. What we did. Then
Yes, sir.
next. Now take this thing here. A fish rising vertically upwards with a uniform velocity 8 meters per second observes that a bird is diving vertically downwards towards a fish with a velocity of 12 meters per second. If the refractive index of water is 4 by 3, then the actual velocity of the diving bird to pick the fish is. So let's understand this thing here. Now here we need to find the velocity of the bird, actual velocity of the bird to pick the fish we need to get. That is velocity of a bird we need to find basically. Right. So see this thing what they given, a fish is rising vertically. So this is the velocity of fish given as 8 meters per second. So let us consider here, this is the surface. And here we have some fish is present here. Now this fish is moving upward direction with a velocity given. Okay. So, and if we call this is the velocity of a fish, and assume that the fish is at some distance from the surface, this distance I am calling it as something x. Okay. Now see this thing here. Fish is here. Who is observer? You tell me now. Who is the observer here? Fish is observing the bird, or bird is observing the fish here. So they are talking about fish rising vertically upwards with a uniform velocity. This much observes. That means who is observer? Fish is observer. Fish is observer. Observes that a bird is diving vertically downwards. So let us consider here is some bird is there. This bird is moving downward direction. Let us consider this distance. We are assuming it as something y. That is actual distance. With certain velocity, the bird is moving downward direction. This is the velocity of a bird. See, this is the velocity of a bird with respect to what? Tell me. This is the velocity of a bird with respect to the fish. Anna board, what are they given now? Fish is observing the bird. That means the bird is coming with this much of velocity. This is the velocity of a bird with respect to fish. Is this point clear? Understand the terminology what they given? This is 12 meters per second.
Yes,
they given. If the refractive index of water, so obviously this bird, this medium is air and this is a water. Right. So refractive indices. So here the refractive index which is equal to 1. Here the refractive index is a 4 by 3 water. Now here who is observer here? Here fish is observer. Fish is observer. Now tell me now here. If the fish is observer, we need to find the apparent depth of the bird with respect to fish will find. the distance of the board with respect to fish. Okay, so this we are calling it as apparent depth. Apparent depth. This is the apparent depth of what? Tell me now. This is the board with respect to fish. Apparent depth of the board with respect to fish, which will be equal to what? Tell me now here. Refractive index of observer. Observer का refractive index is how much now? 4/3 now. 4/3 into. Next, now you can see from here to here, this distance is x. That is what we can say, x by this refractive index of this medium, which is equal to 4/3 plus this one. So this distance is y. Refractive index is 1. This point clear? Tell me.
Yes, sir.
Now, so from this we can get it as a apparent depth of the board with respect to fish. When you multiply, it will come x plus 4/3 into y will come. Now this is the depth distance. Now we are differentiating this thing, we can get velocity. Now here apparent depth of the board with respect to fish, differentiating now, then will come it as what I will now, dx by dt plus 4/3 into dy by dt. Okay, so this is nothing but what I can say now, velocity of the bird with respect to fish only now, and which is equal to dx by dt, that is a fish velocity. We can write this as vf plus 4/3 into, this is the bird velocity of a bird. That velocity of a bird we need to find now. So tell me now here, this value we have a 12 given, vf given a 8 plus 4/3 by velocity of a bird, actual velocity of a bird. Simplify and get it. How much will come? So this is 4/3 into VB, which is equal to 4. 4 cancel. So that means VB value how much now? 3 meters per second. Okay.
Yes, sir.
Understood?
Sir,
Any doubt in this thing?
Sir, in the orange one, that first step you wrote, sir, like dbf by dt. So why did you write it like that?
So we are differentiated. This is what element of distance na. This equation is what element of distance? We need
Yes, sir.
what element velocity. So for that we have differentiated. If I differentiate now, distance will get velocity. We have the problem is completely in terms of velocities we have now.
Okay, sir, understood.
So I have differentiated this thing. This is what tell me now, depth, apparent depth we have differentiate now. This will get the apparent velocity of the bird with respect to fish will get, right?
Yes, sir, understood.
Next one. An ice cube has a bubble inside. When viewed from one side, the apparent distance of the bubble is 12. When viewed from the opposite side, apparent distance is given 4. if the side of the ice cube is total is 24, then they ask him to find a refractive index of ice cube. Yes, did you understand the problem?
Yes, sir.
So here is a ice cube, consider. Now, so here the person, let us say the person who is observing from this side, observing from this view, he found that this ice cube is at one location. He is viewed from one side, apparent distance of the bubble. So that is, he felt this one, the bubble is here. Yes, that means this distance is given. Yes, he observed that this distance is 12 centimeters. When viewed from the opposite side, apparent distance of the bubble, which is given as, when viewing from this view, this side, he has given this as an apparent depth. So this is, the bubble is here, isn't it? You'll find this type of thing in a paper weight. We'll find the bubbles are there. So one side will be appears at one location, other side will appear some other locations, right? So that is the concept of apparent depth. Due to the apparent depth, it will appears like this due to refraction of light. And the total, this distance, which is given as, what tell me now? Total thickness of this ice cube is given, each side given as 24 centimeters. Now you can see now here, first of all, now let's find out this apparent depth now. So when you are viewing from this view, right side, so this is apparent depth. If I call this as a D1, so it should be equal to what, tell me now? Let us say actually the ice cube may be somewhere here. So inside the bubble may be somewhere here, consider. And from here to here, this actual distance, this is, we can say this as a T1. And this from here to here, this actual distance, it may not be midpoint, right? That's why we have taken T1, T2s. So here is actual bubble. Okay. Now this apparent depth, which will be given as, what we can say, tell me now, this is T1 by refractive index, tell me now. The man is observing from the air. Okay. From this, can I get the T1 value? T1 is equal to what, tell me now? Mu into D1. Okay. Similarly, can you tell me now T2, which is equal to mu into D2 now? If I add these two here, T1 plus T2, then will come to be a what, tell me now? Mu into D1 plus D2. And you see this thing T1 plus T2, this is T1, this is T2, which is nothing but total side only now, tell me. T1 plus T2, which is nothing but side, isn't it? How much is value? 24 given, which is equal to mu by D1, D2 values, one is 12, other one is 4. So we can get this mu value, tell me now, that is 24 by 16. So how much this value, tell me?
3 by 2.
Yes. 4 fours. This is 4 6. 2 twos and 3s now. So mu value, which is equal to what you tell me now, 3 by 2. Got it?
Yes, sir.
Next, this is another important problem. This is one of the mains question. Read the problem carefully. An observer can see through a pinhole the top end of a thin rod of height h, as shown in the figure. The beaker height is 3h. The radius given as h. When the beaker is filled with a liquid up to a height of 2h, he can see the lower end of the rod. Then the refractive index of the liquid is. Understand the problem?
Yes.
See what you understand. What you understand in this problem, tell me. So
Sir, when he sees the pinhole, you can see the bottom of the rod, and the beaker height is 3h, and its radius is h. And when it's filled with a certain amount of liquid, you can see the bottom end of the rod, and we have to find the refractive index.
Yes. So basically, fine. First, initially the person is observing from here. So here he can able to see the top of the rod. He can able to see when there is no water is filled. Right. So if you let's find out these angles now here. Now here this is how much this value? How much this value? And this is 2h. And how much this value?
2h.
Yes, this is 2h. Now, so if I call this angle is something, so here this person can able to see here. Now I'm calling this is the normal. If I call this is the, let us say, theta. Tell me theta. From the triangle. So tan theta equal to how much now? Which is equal to 1 now.
Yes, sir.
So how much the theta value? Yes, so we got the theta value 45 degrees. That means initially the person is observing at an angle of 45 degrees. He is observing. Right. Now see what happening now here. Now, so we added certain amount of water is added. So in this beaker. So how much this water is added? 2H level we have added. Right. Next, now here is the rod is there here. Now this person who is observing here, that means now here the person is observing at the same location, right? So here only the person is there. He is observing here. So now he can able to see what? Tell me now. Bottom of the rod he can able to see. That means, so this light rays which are coming. So this light ray which are coming here, up to H height there is no water, right? Now thereafter light ray has to bend to this bottom now, isn't
Yes,
it? Now here at this location, if you draw a normal we have drawn here. So let's observe here. Now here, this is the angle. So this is the angle. So the light ray has to go like this. Then light ray has to incident on the person eye. Now if we call this is the eye, and here this is R. Now look at now here, how much this angle here?
R.
This angle R, and this angle. So this is nothing but this angle only na. Initially the light ray which is coming, like the person is at the same position, isn't it? The person angle not changes, but the light ray get deviated because of the medium, isn't it?
Yes, sir.
So how much this R value must be? This must be a 45 degrees now. This R is 45 degrees. Clear this point? Tell me.
Yes, sir.
Now, so here this height, how much this height is a H? 2H height we have filled with the water. This is 2H, means this angle 45 means this must be a height. This must be a H only now. Tell me. Isn't it?
Yes, sir.
Now you can see now. If you draw these lines here, now you can see. Now,
Sir, how do you know the height is 2h?
2H height, the water is filled now. How much height is filled?
Okay, sir, understood.
2H height. Right. So now you can tell me now here. So this is H. This part, this from here to here. This is H means this must be H only na. Radius is 2, total diameter is 2H.
Yes, sir.
Right. Now this is 2H, right? Now we'll try to apply the Snell's law here. Now this medium refractive index is mu. And this here, this medium is air only na, refractive index is 1. So let's apply the Snell's law now here. And which will be equal to what? Tell me now. This is Snell's law. Tell me. This is mu. Okay. So mu into what? Tell me now, sine I. And which will be equal to 1 into sine R na.
Yes, sir.
1 into sine R. Sine R value 45 degrees. Then we need to have this mu value we need to get. That is mu into sine I, which will be equal to 1 by root 2. Now, so we need to get the mu value we need now. Refractive index we need now. So the refractive index, which will be equal to, this is 1 by root 2 into sine I. Tell me now, I value we need to get now. So here you can see now, this is H and this is 2H. So we can get this one now here. How much this one? Right angle triangle na.
Root 3h.
Yes, so that is how much now? 2 square, na? 2 square. Root 5.
Yes, sir, 5h.
Root 5h, isn't it? Now from this
Yes.
sin I, so from the triangle sin I value, tell me now. Sin I, which will be equal to h by root 5 into h. So sin I value how much now? Root 5. 1 by root 5. So it will come to be a what, tell me now? 1 by root 2 into this is root 5 now. That means how much we can say now? Square root of 5 by 2. Okay. Done. So that is a refractive index of a medium. Hmm? Understand?
Yes, sir.
Hmm. Understand or any doubt in this thing? Feeling any
No,
difficulty in
sir.
this one? Clear now? Hmm.
Yes, sir.
Yeah. Sure. We'll go to the next one.
Yes, sir.
Next. Critical angle. Critical angle. See this thing, this is another very, very important topic. So let us consider this is some medium. We have taken two separate mediums we have considered, and here this is a normal. So assume that this light ray, which is this is a denser medium, and here this is a rarer medium. The light ray which is moving from the denser to rarer medium, consider. So this is the light ray which is moving from denser to rarer. Now this is the angle of incidence I. Tell me what happens when the light ray moves from denser to rare. In which direction the light ray will bend? Towards a normal or away from normal?
Away.
Away from the normal. So this means this light ray which will bend like this now. Now this is the angle of refraction now. Now again, if I increase my angle of incidence, what happens? If I increase my angle of incidence further, what happens? Then the light ray will move further, will bend or not?
Yes, sir.
Yes, the light ray will further will bend, and so it will be almost bend will be come to the x-axis. So now I'm increasing my angle. Further, if I increase now here, this is now this light ray, so it will become like this now. It will lies like this. It will be lies only on the surface only. Now this is what, tell me now? R, angle of refraction. How much is angle of refraction now in this case? 90 degrees now. Angle of refraction is 90. So this is now, this is the angle of refraction. It will becomes 90. Then this angle of incidence is there now. This is called as a critical angle. Understood? The angle of incidence in the denser medium, critical angle is nothing but what is the angle of incidence basically, for which the angle of refraction in the rarer medium becomes 90 degrees. Understood? This is called as
Yes, sir.
critical angle. Now let's see this thing. Let's analyze now here critical angle formula. So this is the denser medium. So that's why refractive index I'm calling it as a mu d. This is a rarer medium refractive index. We're calling it as mu r. So let's apply a Snell's law. Now when we apply a Snell's law, tell me now here. Here this refractive index of this medium. So this is mu d into angle of incidence. This is I, which is equal to what? Tell me now, mu r into angle of refraction r. So here, if angle of refraction, if it is 90 degrees, then angle of incidence is what? Tell me now, theta c. Now we'll put these two conditions in the above relations. This is mu d into I is equal to theta c, which is equal to mu r into what terminal? Sine 90. Sine 91. So will come to be what terminal here from this? Sine theta c, which is equal to what you tell me now? Mu r by mu d. So from this, finally the critical angle, which is equal to what you tell me now here, that is sine inverse of mu r by mu d. Okay. So critical angle, the formula is what? Tell me now, sine inverse of mu r by mu d. Right?
Yes, sir.
So now look at now here. So if the angle of incidence is less than critical angle, then what happens? Angle of incidence less than critical angle, then what happens? We need to see. What happens, you tell me now? Then the light ray is
Sir, but
refracted. Light ray is refracted to the second medium. Yes or no? If the
yes, sir.
angle of incidence equal to critical angle, then the light ray lies only on the surface only. Only on the surface. And if this angle of incidence is more than critical angle, then what will happen?
It will be in the same medium.
If the angle of incidence is more than critical angle, if it is, now here this is a light ray is incidenting here. If I call this is the I, this I is greater than critical angle, then the light ray does not enter into the other medium. It is reflected back to the initial medium only. Okay, it is reflected back to initial medium only. So this is a rarer medium and this is a denser medium. Then this phenomenon is called it as a TIR. total internal reflection. What we'll call this as a TIR, total internal reflection. Okay. The condition for TIR is what? Tell me now. It has to satisfy the two conditions. The first condition is the light ray has to move from denser to rarer. The first condition. Then only can happens. Light ray can move from denser to rarer. First condition. And what is the other condition? Angle of incidence must be greater than the critical angle. If these two conditions satisfy, then only the TIR is possible. Okay. Now here you need to observe the three conditions now here. If angle of incidence is less than critical angle, then what happens now? A refraction takes place. In this case, a refraction occurs. And if the angle of incidence equal to theta c, then what we can say now? In that case, we can say now here light ray gauges the surface. Light ray gauges the surface. Surface means it will lies only on the surface only. It will just lies on the surface only. It will be not in the rare medium or not the denser medium, just like a layer. It will be lies like this. Yeah, we have seen this is called as a gauges the surface if the I is equal to theta c. Next, third one, if this is I is greater than theta c, then what happens now? TIR occurs. Okay.
Yes.
Copy these things.
Yes.
Now, see what the TIR means. The total internal reflection. When it can happen, you see. So, means what? Tell me now here. The angle of incidence in the denser medium, if it is greater than the critical angle, then what happens? Then the light is sent back to the same medium. This phenomenon is called as a TIR. And the condition for TIR is what? Tell me now. Light should travel from denser medium to rarer medium. Keep in mind. Should be denser to rarer. And the angle of incidence should be greater than the critical angle. Done?
Sir, I'm writing applications. 1 minute. Yes, sir.
So these are some of the applications of the TIR. The working of optical fibers. Nowadays, all the wireless cable wires are there. Now, all these are manufactured with these optical cables. These optical cables working based upon the TIR and the formation of mirage and the formation of looming and sparkling of diamond will comes under these categories. Fine.
What is looming?
Looming, it is like in cold countries. So, do you know about the mirage?
Yes, sir.
So here in mirage, you can observe this thing in the hot countries, hot location, desert. You can see, but looming is a similar type of phenomena. This will happens in the cold countries. If it is very cold, you can find. Similar to the like a mirage only. Inverted image will be formed. That inverted image is comes under the looming. And the sparkling of diamond. Once the light ray is entered into diamond, that light ray does not come out of the diamond. So the light ray will experience the diamond has been cut in such a manner, the light ray will be continuously get refracted. So you have a TIR. So light ray does not come out from the diamond. So it will be once the light ray entered, so it will be permanently in the inside the diamond only. So due to continuous TIRs will happens, the diamond will sparkle very bright. Okay.
Yes, sir.
Next, circle of illumination. Circle of illumination means now let us say here we are talking about this is some denser medium. We are taking this example which will be a water we have taken, and here this is a air. Imagine now here there is some object is there. It might be some light source we have placed now, or we can say this here we have some fish is present. Now fish is trying to the light ray is placed here, and the light ray which is coming like this normally, it will straight away the light ray will go without any deviation. Now, so let us say one more light ray which is coming, it will incident at this location, this light ray. Now you tell me now here, if the angle of, this is the angle of incidence, this we are calling it as I. Now you tell me now, if the angle of incidence equal to theta c, what will happen? Here we have taken I. If this I is equal to theta c, what will happen?
It will graze the surface.
Yeah, it will grazes the surface like this. Okay. Now, if the angle of incidence is greater than theta c,
Total internal reflection.
so that means now if it is greater than theta c, in this case, what happens now? The light ray will come back to here only in the initial medium. Right, the same thing
Yes,
will
sir.
happen this side also, isn't it?
Sir, I have a doubt, sir.
Hmm.
In total internal reflection, will angle I be equal to angle R?
No, no. Angle I, so here you're talking about this angle you're talking.
Yes, sir.
So this is angle of incidence equal to angle of reflection. First law we have seen now. Yes, that's satisfying. This is also equal to I only.
Okay, sir.
Now look at now. The same thing will happen the right side also, left side also, both side will happen now. And this is I. Okay, if this I is also greater than theta c here also, same phenomena can happen. So now tell me now. And this light ray will experience a TIR. Okay. Now you see this thing here. The person who is observing, let us say, the person who is observing here, the person can able to see which part of the light rays can able to see. You tell me now. In this region here this is angle is greater than theta c. Now you tell me now, if the light rays, so many light rays will fall here, here also will fall now,
Yes, sir.
isn't it? So that means this light rays, what happens now? Will this light rays will enter into second medium or not?
They will enter.
They will enter. If they will enter, the person can able to observe this light rays now, isn't it?
Yes, sir.
Now you see this thing here, the person cannot able to observe this is light rays whose angle of incidence greater than theta c, not able to observe now. Up to theta c he can able to observe, yes or no? And this light rays, all this region, the person who is observing all this region will appears to be a bright region, you see the, isn't it?
Yes, sir.
And the remaining region, how it will appears? The remaining part will appears as a dark region, yes or no?
Yes, sir.
Now, so that means as a result, how it will happen, you see this thing. So here this region, we can see now this part of region will appears to be a bright. Like this will form one circle will be formed, of course a three-dimensional view will form, one circle will be formed now like this, like a cone जैसा form करेगा, isn't it? Only this
Yes, sir.
region, this region will be appears as a bright, remaining regions will appears as a dark. The same thing here. If we have in place of this light source, let us say here some object is there, some fish, some is there. The fish can able to see only this part of region only can able to see. And beyond that, when the light rays does not enter into this region, the fish cannot able to see this part of region. Right. This is called as a circle of illumination. That region is will appears a very bright. That is a circle of illumination. And so we can see now this will be certain radius, we can say now. If I call this is R is this radius. This radius of this part, the circle is R, and this height is H. Now this angle which is equal to theta C, then this angle is also theta C only now. Now from this we can able to get the tan theta C. Tell me from the triangle. Tan theta C which is equal to R by H. Then R is equal to what? Tell me now. H into tan theta C. Okay. This is the radius of the circle will form. And if they ask him to find the area of the circle, area which is equal to pi r square, so which will be equal to pi h square into tan square theta c. This is the area. And this theta c which is called as a vertex angle. This theta c a semi-vertex angle. The vertex angle means the total angle is vertex angle. That means 2 theta c, which is equal to how much now? 2 into theta c. Okay.
Yes, sir.
So here are things what you have to understand here. So this formula is important. Finding the radius of the circle. They may ask to find the area. They may ask him to find. If we know this R, we can get area and the vertex angle. What is theta c now? Tell me. Theta c is a critical angle which is given as what? Tell me now. Sine inverse of mu r by mu d. Mu r by mu d. Okay.
Yes, sir.
Right.